Okay, hi, and welcome to today's lesson on sum and difference identities for tangent. The previous 2 days, we've established the sum and difference identities for both sine and cosine, and they're listed here just for your reference. We're actually going to use these to help us derive sum and difference identities for tangent as well. Okay, now one thing to sort of help us along with this process, okay, we do need to recall the basic relationship for tangent. Now we know from the quotient identity that tangent of x is simply sine of x over cos of x. Now if we're interested in coming up with sum and difference relationships for tangent, it should follow that, you know, if I'm adding two angles or subtracting two angles, as long as it's the same two angles, I should have a similar looking relationship with regards to tangent. So it should follow that tangent of x plus y should simply be sine of x plus y over cos of x plus y. And for similar reasons, it should also make sense that tangent of x minus y would be sine of x minus y over cos of x plus y. Technically, as long as the argument or the angle portion of these expressions matches what the angle is represented by, whether it's a sum or difference or even a product, let's say, of angles, as long as I'm using the same angle for sine and cosine, I can relate it back to tangent. Okay, so we're going to keep this in mind as we develop the sum and difference relationships for tangent. So we're going to start with tangent of x plus y. So just to sort of reiterate what was said on the previous page, now given what we talked about the last couple days, we actually have identities that can be used both top and bottom here. So the sum identity for sine of x plus y should be sine of x cos of y plus cos of x times sine of y. So that would be my new numerator. And then similarly, cos of x plus y should be cos of x, cos of y. Now it would have to be minus sine of x times sine of y. Alright, what we want to now do is actually get an expression for the tangent of the sum of two angles to be actually in terms of tangent as opposed to sine and cosine. So what we're now going to do is divide both the top and bottom of this expression by a common expression. So the expression we're going to divide both top and bottom by, as it turns out, we're going to see why we're going to do this momentarily, we're going to divide each expression by cos of x times cos of y. So what we'll end up getting when we have that done, so again we're looking at tangent of x plus y, so picture on the top sine of x cos of y, I'm now dividing that by cos of x times cos of y, and then I'd be adding cos of x sine of y divided by, again, cos of x, cos of y. So that would be my new numerator. My denominator is going to be, so picture cos of x, cos of y. Now notice I'm actually dividing this by itself. So picture, we're going to be able to simplify that momentarily, and I'm subtracting sine of x, sine of y, by cos of x, cos of y. Okay, so in our next step, we're now going to just see, is there anything I can reduce? Is there anything that can be simplified here that makes the expression that we have equivalent but in simplest form? So in the first expression, I actually noticed that there is a cos of y in both the numerator and the denominator, so those would be able to divide themselves out. Similarly, in the next expression, I see a cos of x in both the numerator and the denominator. They will divide each other out. And what that would leave me with so far, so if we're looking at just the top now, we'd have sine of x over cos of x plus sine of y over cos of y. So there's our new numerator. And then in the denominator, if we go back to the step above for a second, I would be able to divide the cos of x's into each other as well as the cos of y. So since I divided something by itself, the end result is I just am left with 1. Okay, now the next expression, unfortunately nothing would simplify, but what I'm going to do is actually split it into sort of two pieces. So I'm going to look at this as sine of x over cos of x times sine of y over cos of y. So we're kind of one step away from having the identity where we want it. Now what I would draw to your attention is in the numerator, sine of x over cos of x, that is just simply equivalent to tangent of x. And similarly, the next expression, different angle, but same idea, would be tangent of y. And then we're going to be over 1 minus, well, that first expression is equivalent to tangent x, and the second to tangent y. Okay, so here is the sum identity for tangent. Now, we're going to compare what would happen if it was actually a difference between x and y rather than a sum. The identity will look very similar. What we now have are the following two new identities. Okay, so this brings to the total 6 different sum and difference identities, 2 for cosine, 2 for sine, and now we have 2 we can use for tangent. Right, so what we're going to now do is incorporate these two new identities into some examples that are similar to what we've looked at the last couple of days. Okay, first example. So this simply says to simplify the following expression and represent it just as a single trigonometric function. So what I would need to look at here is kind of the top and the bottom collectively. One thing I would sort of focus on is, well, I see a sum of tangent expressions, so two different angles on the top, and then 1 minus the product of those tangents in the bottom. So what I want you to think here, think in terms of it would have to be the sum identity, simply because I'm adding on the top. So the sum identity now, the one thing I have to realize here is what my two angles are. So the first angle inside that first expression would be 4w. The second angle is z. So what I'd be able to do is simply say, well, this is just the sum of those two angles, so it would have to be 4w plus z. Okay, now in this case, w and z, those aren't like terms, so I wouldn't be able to simplify that any further, but now I have a single trigonometric function representing the expression that we saw there. Okay, so we wouldn't be needing to do anything else with this expression. We have simplified it. Example 2. So this is now asking us to do a calculation. So it says to find the exact value of tangent of 11 pi over 12. Now, what I will highlight to start with here. Okay. Now, when it says exact, okay, keep in mind no decimals. For sure. Another thing, may need to use special triangles. So what I would draw to your attention here, 11 pi over 12 is actually not on its own a special angle. What we can try to think of are angles that maybe I could combine somehow to produce 11 pi over 12. Okay? Now, what I also want you to picture is 11 pi over 12 is in the second quadrant. All right? Now, given that it's going to be in the second quadrant, our ratio should end up being negative simply because we're doing tangent. Tangent is negative in both the second and the fourth quadrants. Okay, so what we could do here, we've got 11 pi over 12. Let's think of some fractions that if I combine them together, I actually get 11 pi over 12. So we have some different choices here. For one, we could try, say, 8 pi over 12 plus 3 pi over 12. Now, the nice thing about both of those expressions, I can actually reduce those. Okay, both of those fractions are not in lowest terms. Now, if I simplify 8 pi over 12, I'm going to get 2 pi over 3. So that is equivalent to 2 pi over 3 plus, and now 3 pi over 12 is actually equivalent to pi over 4. Now, if we have a look at the two angles that are here, notice this one is actually a special angle. So that's good. We want to actually work with an angle like that. And if we look at the other one, now 2 pi over 3 itself doesn't happen to be one of the angles within the two special triangles we know, but if we think in terms of the related acute angle, it would have to be, in this case, pi over 3. So this also is a special angle. Okay, so what we're going to be able to do here, and the reason this relates to this lesson, is I can take an angle like 11 pi over 12 and split it into a sum of two angles that actually add up to the same thing, but will allow me to do some exact calculations, whereas, say, 11 pi over 12 on its own would not. Okay, so we can use 2 pi over 3 plus pi over 4 and incorporate it into the sum identity for tangent. What we would be able to conclude, so we're going to say, therefore, tangent of 11 pi over 12, that will simply be equal to tangent of, and keep in mind what our angle split was going to be, 2 pi over 3 plus pi over 4. So 2 pi over 3 plus pi over 4. And now what we'll do is we'll actually use the identity we just established a few minutes ago. So this would become tangent of 2 pi over 3 plus tangent of pi over 4. And I have to divide that by, it's going to have to be 1 minus the product of those two tangents. So 2 pi over 3 times tangent of pi over 4. Now, what you may need to do at this point is just to sort of visualize what these ratios are going to be equal to. You could picture sketching a couple of diagrams. So for instance, if I'm trying to work out exactly what that is equal to, maybe off to the side here I want to just do a rough sketch of what 2 pi over 3 is. So picture that angle would be right there. So there's 2 pi over 3. I would need to picture my right triangle. Now the related acute angle here, as I said before, would be pi over 3. So if I envision the side lengths opposite to that and adjacent to that, I would have to have root 3, 1, and 2. And if I focus on what the coordinates of that point right there would be, I'm in the second quadrant, so I know my x-coordinate's negative and my y-coordinate is positive. So that would allow me to figure out the tangent ratio for 2 pi over 3. So I'm going to write that in. So we're going to know automatically, looking at that diagram, if I do the ratio of y over x, which is what tangent ratio is equal to, I should end up getting root 3 over negative 1 here. I'm going to have to add. Now for the other ratio, which is tangent of pi over 4, hopefully that one you could kind of picture without a diagram, but I'll do a quick one just to sort of help this along. So pi over 4 is in the first quadrant, which is right there. And if you draw in your triangle, as it turns out, so if I picture opposite and adjacent sides, those would be 1. My hypotenuse would be root 2. So that point would be 1, 1. So the tangent ratio for pi over 4 is simply 1. Okay, and then my denominator, I'm going to have 1 minus the product of these things. So picture root 3 over negative 1. times 1. So now it's just a matter of actually simplifying this, and we would be done. So root 3 over negative 1, I'm just going to write that as negative root 3 plus 1 over, and then this is going to be picture 1, but I'm actually subtracting the product root 3 over negative 1 times 1, which is actually a negative expression. So this will simplify to 1 plus root 3. Okay, that would technically be my solution. Now what you may or may not be asked to do is to actually reduce that by multiplying top and bottom by the conjugate. So that's what I'll do here, just sort of for more practice than anything. Now to rationalize the denominator, you have to multiply by what's called the conjugate. Now it would be the conjugate of the denominator. And the conjugate is simply the same binomial expression with the opposite sign separating the terms. So that would be, I would have to literally go 1 minus root 3 over 1 minus root 3. It's the equivalent of multiplying by 1, but what it will allow me to do here is get rid of the radical expressions from the denominator. Okay, so what I would now need to picture is, on the top and the bottom, I'm basically multiplying two binomials together. So on the top, if I use FOIL, the first term would have to be negative root 3, and then the next is going to be negative root 3 times negative root 3, and then the second term in that first expression has to multiply the other two terms. Now negative root 3 times negative root 3, first of all, would be a positive term, but if I do a square root times itself, I can simply drop the square root sign. Okay, so now I would have 1 times 1, so I'm going to be adding 1, and then I have to subtract root 3. Now on the top, we've got that taken care of. The bottom, I would have 1 minus root 3 plus root 3, and then I have to now, in this case, subtract 3. Now notice what would happen in the denominator. The reason I did what I did, those two middle terms end up eliminating themselves. So I would be left with, if I simplify the top, I'm going to have 4 minus, now negative root 3 minus root 3 is actually going to be minus 2 root 3. In my denominator, I'm left with negative 2. And what I can now do is look at the top and say, well, 2 is a common factor. I'm going to divide it out. So I'd be left with 2 minus root 3. And if I divide, if I'm dividing by negative 2, notice my final answer in this case could be written as 2 minus root 3 over negative 1. Or we might want to just do the actual division, so negative 2 plus root 3. So that would be completely simplified, the solution we would get here. Okay, final example for today, and we have done questions similar to this the last two lessons, so same basic idea. We're now just incorporating tangent, the sum and difference of the two angles, because we hadn't had a chance to do that until now. So if we look at what we're given here, we're given that sine of angle A is 5 over 13, and we're told that specifically that angle is between 0 and pi over 2, so picture that being the first quadrant, and then for angle B, we know that cosine of angle B is negative 8 over 17, so it's a negative ratio, and notice the quadrant that I'm in, cosine is supposed to be negative in the second and the third. This happens to represent the third quadrant. Now what it wants us to evaluate here, it wants us to evaluate tangent of A plus B and tangent of A minus B. So now that we know what the identities for those look like, what we could do is just sort of expand upon them so we can figure out, you know, what we need to actually determine here. So tangent of A plus B should be tangent of A plus tangent of B, and I would have to do 1 minus tangent A times tangent B, and then notice the other part of this question, which is the difference. We're going to start with, so for angle A. Now we're told, just to recap, that angle A, we know that sine of angle A is equal to 5 over 13. Now what to keep in mind here, sine is actually the ratio of y over r. We can use Pythagorean theorem. Now normally I actually have two options as to what x can equal here. Normally I would say it's either positive or negative 12, but I have to keep in mind what quadrant it says angle A is in. It's supposed to be in the first quadrant. Now I know x would be positive there. So notice I'm going to just say, well, x is positive 12. Now what this would allow me to state, now that I know x, so tangent of angle A is supposed to be the ratio of y over x. Now that I know x, so it's 12, and we knew that y was 5, so tangent of A is going to be equal to 12 over 5. Now we got a positive ratio here for tangent, which makes sense since we are in the first quadrant. Okay, so we've got kind of half of the information that we were looking for. The next part would be, okay, let's look at angle B. And to recap what we were told about angle B originally in the question, we knew that cos of angle B was negative 8 over 17. So cosine of B is, now I'm going to put the negative sign specifically with the 8 because I know the r value must be positive. R is always a positive quantity, so that only leaves x being negative as the possible option. Now again, normally there are two answers to this, either positive or negative, whatever the square root of 225 is. That happens to be 15. Now based on the quadrant we're supposed to be in, it told us that angle B was in quadrant number 3. Now in quadrant number 3, y would have to be negative. So I'm going to go with y. It's got to be negative 15 here. Okay, and for similar reasoning from before, what I would now be able to conclude, now that I've figured out what y is, notice tangent of B is going to be the ratio of my y value over my x value, so it would be negative 15 over negative 8. But notice I could simplify that, because both values are negative, I would get positive 15 over 8, which makes sense because in the third quadrant, tangent is supposed to be actually a positive ratio. Right? So now for part A would be tangent of A, which previously we had worked out that was equal to 5 over 12, and we just finished determining what tangent of B is. So tangent of A plus B is tangent A plus tangent B, so the top is going to be 5 over 12 plus 15 over 8, and then in our denominator we're going to have 1 minus the product of tangent A and tangent B, so 5 over 12 times 15 over 8. So all I need to do now is actually simplify this, and we are going to have it the answer we want. So if I look at the top, I would want a common denominator. Now between 12 and 8, they both divide evenly into 24, so I'm going to convert the first fraction to 10 over 24, and the second fraction, if I multiply top and bottom by 3, I would get 45 over 24. And then in the denominator, I've got 1 minus, so if I multiply the tops together, I'm going to go 15 times 5, which is 75, and 12 times 8, that is 96. Okay, so we're kind of working our way towards being done. We're not quite there yet. So now, if I look at the top, I can add. So I would get 55 over 24. And in the denominator, I want a common denominator to work with. So I'm going to go 96 over 96 minus 75 over 96. So this would be 55 over 24. And then in the denominator, 96 minus 75 happens to be 21. So I've got 21 over 96. Now keep in mind, I'm actually dividing two fractions. So to tidy that up, when I'm dividing fractions, I can convert by just saying, well, that would be the same as inverting and multiplying the denominator. What's in the denominator? So I'm going to have 55 over 24 times 96 over 21. Okay, and what I could do at this stage is look to see, are there any values that go in evenly into the expressions? As it turns out, 24 divides into itself once and actually goes into 96 4 times. Alright, so 55 and 21 don't happen to have anything in common. So what I would do now is say, well, 55 times 4, that is 220, and 1 times 21 is 21. So I've just worked out the tangent of A plus B. That's going to have to equal 220 over 21. So part A is now answered. And for part B, so keep in mind part B wanted tangent of A minus B. Now the only difference between tangent of A minus B and tangent of A plus B is the signs of the expressions top and bottom. What I was adding, what I was subtracting. So I'm going to go up here for just a second. Okay, literally all that we would need to change about what we had done up here is I would need to switch that to a subtraction sign and that to an addition sign. So pretty much what we would be able to do is take what we had at this point here and then just switch around whether I was adding or whether I was subtracting. Okay, so that is what I'm going to do. So I'm going to jump right to the fact that this would have to be 10 over 24 minus, instead of plus, 45 over 24, and that is going to be, so picture 96 over 96. I've just gone to the common denominator right away, and then plus 75 over 96. Right, so now if I do a simplification of the numerator, I'm going to have negative 35 over 24, and in my denominator I'm actually going to have 171 over 96. So like I did a moment ago, I'm going to invert and multiply here to sort of finish simplifying what we have. So this is going to be times 96 over 171, and I already knew from before 24 goes into itself once, into 96 4 times, and as it turns out 35 and 171 don't have any common factors, so my final answer here is just going to be the product of negative 35 and 4, which happens to be negative 140, and that would be over 171. So I've now got tangent of A minus B calculated, and at this point we have answered our question. Okay. If you have any questions about any of the parts of this lesson, they are very similar to some of the things we've already looked at in the previous lessons, but as always, if you're not sure of anything or want clarification, please make sure to ask in class. Have a great night, and see you tomorrow.